In this video, we'll talk about domain of functions from equations. See, we already talked about domain of functions, but we saw sketches of the functions, which is a great way to determine a domain. But let's pretend we're blind. We just see an equation. We still figure out its domain, right? Domain, we're describing what x values are allowed to be substituted in the function to provide y values. All right? A lot of times, the domain is all real values of x. Anything's allowed for x. Anything can be substituted for x. There's no glitches or trouble. But these are two main functions, types of functions, I should say, where the domain is affected. And the domain is not all reals. This is a rational function. Notice the fraction, and we have an x sitting here, a variable, in the denominator. Well, we know in mathematics, you can never divide by 0, correct? So, to determine its domain, just figure out what value of x makes this denominator equal to 0. Sure, you can see it's 2, right? 2 minus 2 is 0. I can write it down, x minus 2 equals 0. So that would be an x equal to 2. But we're saying basically, this is not allowed to be 0. So when I add a 2 on both sides, x is not allowed to be 2. So how do I describe that domain? I guess in words I could say it's all real values of x, except for x equal to 2. And when we write that in interval notation, we start from negative infinity, put a parentheses, put a 2, put an open parentheses, put a union symbol, put an open parentheses 2, and write to infinity. See, what we're saying basically is go from negative infinity to positive infinity on the entire number line, but we have a soft parentheses at 2, basically representing you don't include the 2. That's what a soft parentheses represents. It means go up to about 1.9999999, skip over 2, and start right here at 2.0000001, etc. All right, 2 is not included in the domain, and that's how we express it. But here, in interval notation, what we're really saying is all real values of x except for x equal to 2. Now, how about when you have a square root? See, underneath this square root symbol, you can't have any negative values. So, to determine this domain, x minus 2 must be greater than or equal to 0. And let's just solve for x. Add a 2 on both sides. X is greater than or equal to 2. That's the describing, that right there is describing the domain. But if we write that in interval notation, the lowest x value is 2. We can include it, so I put a hard bracket, a hard closed bracket, and I put a comma, and we go off to infinity. And that describes that domain. Keep in mind, if you're ever in doubt, you can go and graph these functions, okay? That's a goofy looking function, that rational function, but this one isn't so bad. Now, are there any other scenarios? Well, basically, let's just talk about what if it doesn't have this rational expression with x in the denominator, or it doesn't have a square root. You know, we can go on and on and on. F of x equal to x plus 3. Or f of x equal to x squared minus 5x. Or f of x equal to x to the 7th plus 5x squared minus the absolute value of x plus pi, right? And you notice in these three examples, I didn't have this square root. I didn't have an x sitting in the denominator like this. The domain's all reals. Yeah, all real numbers. And we write that as negative infinity to positive infinity. Okay? That's it. You really have 3 scenarios. Part 1, part 2, and this part 3, everything else. Just focus. See if you have that square root. Or if you have this rational expression with an x sitting in the denominator, which can affect the domain. All right? Let's just see. One more. F of x equal to the square root of 9 minus 3x. Yeah, it's like we did before. The 9 minus 3x must be greater than or equal to 0. We'll solve that inequality. We'll have our domain. Yeah, let's just solve for x in this inequality. Subtract a 9 on both sides, will that work? Okay? I have negative 3x greater than or equal to negative 9. What do you do if you divide a negative 3 on both sides of an inequality? You got to switch that direction. So when I divide a negative 3, and I divide this negative 3 like that, and I did this right here, so that I'm isolating that x, I have to switch this direction. So x will actually be less than or equal to a negative divided by a negative, positive. That's your domain, right there. And we'll put that in interval notation. X is lower than or equal to 3. Those are the values that are allowed for x. Like a 2 or a 1, this thing's fine. You put a number higher than 3, like a 4, it's undefined, okay? In the real number system. How do you write that in interval notation? The lowest x value is negative infinity. And the highest x value is 3. We can close that bracket because 3 is actually in the domain. That's it.